we are graphing rational functions, we want to follow these steps. The first thing you want to find typically is your y-intercept. And that's when your x is 0, because you're not left or right at all in your graph. Next thing you want to find is your zeros of your function. And that's when your y is equal to 0, because you're not up or down at all. You also want to go ahead and try to find your wholes and or vertical asymptotes. And that's when your denominator is 0. It's easiest to find your wholes and vertical asymptotes when they're in the factored form. So you'd want to have the top factored and the bottom factored. You have wholes, once again, if you have a common factor in the top and the bottom. Then, when you're looking at your vertical asymptotes, you want to see as you come in from the right side, do you go up towards infinity or down towards negative infinity? And as you come in from the left side, do you go up or do you go down? You also want to go ahead and take a look for horizontal or oblique asymptotes. And that's what happens to your graph as you go far to the right or far to the left, meaning as x goes towards the infinities. So, we want to go ahead and sketch this graph. Well, we need to go ahead and find our domain, but to do that, we have to have the denominator factored, so we'll come back to that one. Your y-intercept is really the easiest one to do, and you want to go ahead and put in 0 for your x. You plug in 0 for all your x's. You get 0 on top, you get 8 on the bottom. 0 over 8 is your 0. But to be able to find our domain or vertical asymptotes or our wholes, we need to have the denominator equal to 0. So all we're going to do is to go ahead and take the denominator, set it equal to 0, and we're going to follow our steps that we just did yesterday to be able to go through and work out our zeros for this and get it in the factored form. So you'd want to go ahead and list your possible rational zeros, factors of 8, all over the factors of 9, list them all out. You want to go ahead and find m. Remember that's your largest number you have up here, which in this case is your 22, over your leading coefficient, plus 1. And so then we end up getting m to be 31/9. Then you want to go ahead and graph it. So put just your denominator, because that's what we're trying to find our zeros on, into your y equals. And then graph it. And then look at your possible rational zeros. And when you graph it, you're going to graph it from a negative 31/9 for your x min to a positive 31/9 for your x max. When we look at our graph then, we get a negative 4/3, a 1/3, and a 2 that appear to work. It's easiest to go ahead and try the 2. So we're going to try 2 into your equation right here using synthetic division. Drop down the 9, multiply, add, multiply, add, multiply, add, and it does work. So we know then that an x minus 2 is a factor. Now, since we only have 3 terms, that means it's going to be quadratic. It's a 9x squared plus a 9x minus a 4. If you're not able to factor that, use your quadratic formula. In this case, though, it does factor. So we now know what our denominator factors into. These two parentheses and into our x minus 2. So let's go back up and write this in the factored form. That's what we just got for our denominator. You'll notice for the top, it's pretty easy to pull out your common factor of x. Now let's discuss your domain. Your domain is everything that, well, everything will work except what causes the bottom to be 0. We were just looking at what caused the bottom to be 0. That was this stuff right here. So your domain's going to be everything except those things, because those are the numbers that cause your denominator to be 0. Now, let's go ahead and find your zeros. To find your zeros, you'd want to go ahead and set this equal to 0, which is really over 1. So when you cross multiply, when you solve that, you only get the top to be 0. Well, what would cause the top to be 0? A 1 and a 0. You also want to go ahead and find your wholes. Your wholes are your common factors that you have on the top and the bottom. In this problem, there is nothing in common on the top and the bottom, so there are no wholes. Your vertical asymptotes then are just what causes the bottom to be 0. So that would be x equaling 2, x equaling, when you solve this for x, a positive 1 over a 3. When you solve this one here, it would be a negative 4 over a 3. Those would be your vertical asymptotes. We also want to go ahead and find our horizontal asymptote. You'll notice here the degree at the top is 2, the degree of the bottom is 3. Remember we said when the degree of the top is smaller than the degree of the bottom, you get a horizontal asymptote of 0. So your horizontal asymptote is y equals 0. We discussed your domain a little bit ago at the top. What we want to do next is we want to take a look at our vertical asymptotes. And we want to say, okay, what happens on each side of these vertical asymptotes? So you want to say, okay, what happens as x approaches our negative 4/3 from the left? Well, the easiest way or place to put that is into your factored form. So when we look at the factored form up here, you put something slightly smaller farther to the left into 4/3 into the factored form and to see what you get, whether positive or negative. And then in this case, when you plug it in, you get a negative here, you're going to get a negative here, you're going to get a negative here, you'll get a negative here, and a negative here, which means the whole top is positive, the whole bottom is negative, and when you divide, you get negative infinity. That's what we're going to do to all these. So then you want to try a number just slightly to the right. Say a negative 1.3. Try it into each one of those, and it changes this right here. The others don't change, so then it's a positive over a positive, so then you get positive infinity. And then you want to just keep doing that for the rest of these. So then you want to try a number just to the left of 1/3, say 0.3. See what you get when you try 0.3 in each one of these, whether positive or negative. Try, say, a 0.4 to see if it's positive or negative, because that means from the right. Then you want to try something just to the left of 2, like a 1.9, to see if you get positive or negative. Try a number just to the right of 2, say a 2.1, to see if it's positive or negative. So if it's positive infinity. If it's negative infinity. We now want to take all this information we just got and graph it. So you're going to draw in your vertical asymptotes. These are the red dotted lines. You want to go ahead and plot your zeros. You want to plot your y-intercept. You know, just to the right here, you go up. Just to the left, you go down. Same thing here. And then you just want to go ahead and connect these. And when you connect these, and you have your horizontal asymptotes, you're going to go ahead and come in, and you know you go up. You know you can't cross your axes down here. And you just connect everything else.